In this video, I'm going to go over RMS current. We just learned in the previous video that the 120 volts that we get from our outlets is actually an RMS value. So RMS actually stands for root mean square, and it's a type of average value. So why is this useful? So I defined the RMS current as the DC current that would deliver the same average power as the AC current. What does that mean? Well, let's take a look at alternating current. So current as a function of time in an alternating circuit is going to oscillate, have that sine wave function that we just talked about in the previous video. So what's the average current through our circuit? Well, the average current is zero because sometimes it's positive, sometimes it's negative, meaning in the opposite direction. Average value is zero. So I average is not a useful value when talking about current in an AC circuit. So instead, let's look at power. Let's consider a circuit that has an AC source and a resistor. And let's talk about what would be the average power dissipated through that resistor. In DC circuits, we learned that in DC circuits, we learned that power through a resistor is I squared R. So for an AC circuit, we would only be able to find the power at a particular time. We could say, well, the power is going to be the current at that time, squared times R, but that's not very useful. However, looking at power can give us an average value of current that can be very useful. So what we're going to do is we're going to say, well, in a DC circuit, power is I squared R. In an AC circuit, when you look at power, or when you're trying to find the average power, you need to square this current value. When you square the current value, all of these peaks become positive, right? These negative current values, when you square this, they're all getting positive. So that's what this bottom picture is showing here. You've got the current squared times R, so that gives you power. And now to find the average value of this power, you find this line in the middle. It's 1/2 maximum current squared times R. So this is the average power in your AC circuit. Now our DC circuit that has the constant current, what we want to do is say, okay, what is the value of this current here that will give us the same average power in our DC circuit that we're getting out of this AC circuit. So let's call this average value in our DC circuit, let's call it the RMS value, and then set this coefficient, whatever's in front of R here, let's set it equal to what's in front of R in our AC circuit. If those two values are the same, then we know that we're getting the same average power out of these two circuits. So this means that I RMS squared is equal to 1/2 maximum current squared. Go ahead and solve for the RMS value. Take the square root of both sides. See what you get. You get square root of 1, which is 1. Square root of the 2 in the denominator here is square root of 2. Square root of maximum current squared gives us I naught. So this is the definition of the RMS current. It's equal to 1 over the square root of 2 times the maximum current. That's the definition of the RMS current. So what this means is that if you had a DC circuit that was operating or had a current equal to this value, you'd have the same average power dissipated through that resistor. Keep in mind that we can define the RMS voltage the same way. So the RMS voltage value is the maximum voltage value divided by the square root of 2. So now that we've defined the RMS value and we're trying to find what is the average power dissipated in your AC circuit, instead of writing that the average power is going to be 1/2 of the maximum current squared times R, instead of using this expression, which is not as useful because it doesn't look like the old expression that we're used to, and we love this one, I squared R. So now we can say instead of writing average power like this, we're going to use the RMS value, and now we can use the regular equations that we're used to, I squared R, V squared over R, or IV. As long as we work with RMS voltages and currents, so we use RMS here and RMS here, we can use the same expression that we learned for DC currents. We can use those expressions in AC circuits as long as all of our values are RMS values. Let's take a look at an example. We have a 120 volt AC power supply connected to a motor which is rated at 100 watts. What's the RMS current in the circuit? So let's write down what we're given. We're given that the RMS voltage is 120 volts, and 100 watts is going to be the average power. We want to know the current. So let's use the expression for power that has current and voltage, and that's the average power equals IRMS times VRMS. So all we have to do is divide by VRMS to solve for the current. IRMS equals the average power divided by VRMS. So we do 100 watts divided by 120 volts, and we're going to get 0.83 amps. And then the other question is, what is the peak current in the circuit? Because we know that when we have an AC circuit, that the current is oscillating back and forth. What's the maximum current value in that circuit? The RMS value, the root mean square, is 0.83, but the peak value is going to be a little bit higher. The peak, or the maximum current, is defined as the RMS current divided by square root of 2. So go ahead and do 0.83 divided by the square root of 2, and we're going to get 1.2 amps. So this was a quick explanation of RMS current and voltage in our circuits. It's going to be a lot more useful to deal with these values when we're trying to figure out current and voltage in our circuits. If you want to use Ohm's law, which we will do in the next few videos, right, instead of using I equals V over R, for example, we can use IRMS equals VRMS over R. So we can use these RMS values in the equations that we've used for DC circuits, as long as we use RMS values for all of the variables.